Hey, it's lesson 6. This is an aspired to do lesson, so really only a few of you will probably be doing this one, only if you're feeling particularly good or you have some extra free time and you want to learn an additional step. This is kind of like the last piece of the puzzle of putting all of this together and showing motion in 3 or 4 different ways if you count motion maps. So what I've got here is a position time graph. I've sectioned it off into 3 different sections so you can see what these look like. We're going to make a velocity graph and an acceleration graph. In order to do that, we need to explain all of the parts. Okay, so we're going to do that by making a quick list. 1, 2, 3, and we're going to talk about each part as we go. So in part 1, let's talk about the slope of the line, right? So we know if we describe the motion here, we're starting behind the reference point in the negative direction, right? But we're going to be moving positive because our line's pointing up. So if we're describing the slope of this line, it's actually positive and it's constant, and that's all we need, right? Now we can take this and we can graph it over here. What's a positive constant velocity look like? Well, it's a flat line right here on the velocity curve. I still have that mistake I keep making, like letting go of the buttons in the wrong order. Okay, that's a flat line, positive constant velocity. I'm going to redraw it so it's actually flat for you. That's pretty close. Okay, so then number 2, we come over here, change back to blue, and we're going to be looking at the second line here. It's flat, right? And if it's flat, it has a 0 velocity, and it's going to stay 0 that whole time. So we come down here, and we're going to mark ourselves out a line at 2, and I'm going to mess it up like 3 times, just like the last one. The pressure is just so immense. So that's number 2, okay? All right, let's get back to it here. Number 3 is negative, right, and constant, so we need to come down here to negative. If we look at the slope, this one's a little bit steeper than this one, so number 3 is going to be a little bit bigger of a velocity than number 1, and we'll tell it's bigger by moving it a little bit farther away from 0, right? Okay, so that's how we would describe that motion. Oh, I forgot to write negative and constant. You guys should have caught me on that one. Probably. Okay, so let's make our list for number 2, because we have to do the exact same thing here for the velocity graph. We want to describe these lines. Okay, it's going to be pretty easy to do because you can see that they're all exactly the same. What's the slope of this line? It's 0. What's the slope of that line? It's 0. What's the slope of that line? It's 0. I don't know what's going on. There we go. It's 0. Ooh, it's a smiley face. Fun. So what's the acceleration going to be? Because acceleration is just the slope. So you use slope to go from position to velocity and use slope to go from velocity to acceleration, because acceleration is the change in the velocity. Just like velocity is the change in the position, right? So if this is in meters and this is in seconds, velocity is in meters per second every second, and the slope of acceleration is actually in what's called meters per second squared, meters per second. It's how much you're moving every second, how fast you're going, or how fast your speed changes every second. So it's how velocity changes. Okay, so that's what makes it kind of weird. But one of the cool things about our acceleration graphs in my class, and in most of physics that you do, unless you get really into some crazy stuff, is that acceleration graphs are always going to be constant acceleration, which is flat, like this. Now that's not what our graph looks like, because our acceleration is the literal slope of these lines, which is 0. So the line for the first part, 0. The line for the second part, 0. Oops. So if you hold down shift, you can draw a straight line. It's the trick, and I keep letting go of shift before I'm finished drawing my line, and it makes it curvy. That one's not straight. And there we go. Okay, cool. So that's 1, 2, and 3. All right there. Okay, now that's what happens when you're talking about the acceleration of objects that are traveling with a constant velocity. If the velocity is always constant, the acceleration is going to be 0. The objects are not accelerating, right? Now let's move down here to the bottom. These are all non-constant velocities, so these are non-constant, right? That means non-constant literally means that the velocity changes, which means that there will be some acceleration. So we're going to have to consider some actual acceleration here. Okay, so I've got 4 parts down here because I wanted to show you every possible scenario. Okay, so we're just going to describe them as we go, actually, if that's okay. I'm going to describe the end behavior of each one. So I'll use red for part 1. I'll change the colors as I go. So starting here, we're going, it's very steep and positive, right? So we start at fast positive, and then we're going to end up at slow, right? So slow positive. Then if we switch over to green here, we're starting at slow negative, right? Or basically 0. And by the time we get to this point right here, we're going to be fast negative, right? Then if we switch over to number 3, we're still fast negative, and then we get slow negative. Then if we switch to number 4, it's very low slope, right? So that's slow but positive, or starting at 0 basically. And by the time we get to the top here, it's fast and it's positive, okay? So in order to build this correctly, we're going to need to put 4 different lines on the graph. So fast positive to 0. Fast positive to 0 looks like this. Fast is far away from 0, right? So the higher in either direction, the farther away from 0 in either direction you go, the faster you're going, okay? And 0 is here, okay? Then we're going to switch over to our green line. So we're starting at, here is a very slow speed, right, which is 0 where we're at. And then we're going to get even faster going negative. So we're actually just making a V shape like that. Then by the time we get to here, we're going to start with part 3. So I need to switch over to blue. Fast and negative, that's here. And we're going to get slow and negative, that's heading back towards 0, isn't it? So we're going to actually head right back towards, did it again, sorry. Going to head right back towards 0. Boop. And then we switch over to the last color, which is the black color, starting slow positive, going fast positive. And that is a crappy version of our acceleration graph. Here's a better one. That's our acceleration graph, everyone. Complete with all 4 parts, 1, 2, 3, 4 by color. I'm going to color code them though, just because I'm afraid that someone who's like colorblind might watch, and then they're going to want to see these things. That should be a 3 numbered, and it only takes me an extra second to make sure this is accessible to everyone, and since I care about everyone, let's do that. Okay, so now let's describe the velocity of each of these lines, or sorry, the slope of each of these lines, right? So we know this object is doing all kinds of crazy stuff, right? It's like on a roller coaster. Now here we've got a fast velocity going to slow, and then 0 going to faster but negative, and then really fast slowing down to a stop, right? So we're going really fast, and then we stop. Then we speed up, and then we're going to slow down again, but we're going the other way. And then we speed up again, getting fast. Okay, great. That's sound effects. I'm sure you love them. Now, let's talk about the slope of these lines, shall we? Do we need to put all 4 of these things together? Do we need to have 4 different descriptions? No, we don't. We can describe 1 and 2 together, and we can describe 3 and 4 together. I'm going to do that for you, okay? So we're going to change colors. We are going to use orange. So 1 and 2 is going to be one color, and then we are going to use, I don't know, pink or something for 3 and 4. Okay, so let's switch to orange really quick. What's the slope? Well, it's negative, and it's constant. What's the slope of this line? Well, it's positive, and it's constant. Right? That means the velocity is changing at a constant rate. It doesn't mean the velocity is constant, because clearly the velocity is going down and then back up, right? So let's graph these 2 things. I'm going to graph the orange line. What's negative constant look like, y'all? Boom. And then what does positive constant look like? Go to that point, tie it off, and we're there. That's it. That's the whole story. That's every possible velocity or acceleration graph you could draw. It's either going to be 0, it's going to be positive constant, or it's going to be negative constant. You can't have curves. You won't even have diagonal lines on your acceleration graph. So acceleration is actually the easiest one. You just have to know how to use slope to get there. So the slope of your position graph gives you velocity. The slope of your acceleration graph, the slope of your velocity graph gives you acceleration. Okay? So it sounds hard. It's actually easy. It's just a matter of using slope. If you can do this part to here, then you can do this part to here. It's easier. Okay? Thanks for watching.